right? So let's see this. The last part of extraction of metal includes aluminium. So
Yes,
how
sir.
to reduce the aluminium? Aluminium cannot be reduced by carbon method, that is smelting. It has to be only done by electrolytic reduction.
Yes, sir.
When it comes to highly reactive metals like aluminium, potassium, sodium, magnesium,
Hmm.
these can only be done by electrolysis in their molten form, not in aqueous form. Because in aqueous form, water itself will reduce more than these metals. So therefore, we cannot use them in aqueous form. You have to convert them into a molten form. Okay.
Right.
So aluminum is also highly active metal, so it is reduced by electrolysis. For S and P block elements, usually electrolysis in their chloride form is chloride, bromide, or iodide form is more used. Okay. In the fluoride form or a in the fluoride form, gas released and it's highly corrosive in nature. Okay. That's why
Okay.
usually we do not use fluoride that easily. Next,
Okay.
now notice in case of aluminum and beryllium oxides, these are used, are used because chlorides have high covalent character. Because in the case of
Yes,
aluminum
sir.
and beryllium, you can't directly use chlorides because of its high covalent character.
Yes, sir.
Now, electrolytic reduction takes place in a fused state. It is done by method called Hall-Héroult process.
Yes,
The
sir.
input what you need to give is the oxide, aluminum oxide, which we got it from bauxite. So bauxite ore
Yes, sir.
has been converted into concentrate, and Al2O3 has a very high melting point. So
Hmm.
first thing what we need to do is to reduce its melting point. So what we do, we take a solvent, sodium aluminum fluoride, which we call it as
Okay.
cryolite. And using cryolite, will because its melting point is quite lower, as we add Al2O3 in the percentage amount of 85 and 10%, then
Yes,
adding
sir.
some more mixture of calcium fluoride, there are two advantages we will notice here. One, the melting point of the entire mixture will reduce. Second, lot of ions will be generated so that electrical conductivity is increased. Okay.
Okay.
So you can say solvent is used due to high melting point of Al2O3 that will reduce the working temperature and it will increase the conductivity. Okay. Calcium fluoride fluorspar can reduce the working temperature up to 950 degrees and simultaneously increase the conductivity.
Okay.
How does it happen? Electrolysis take place in which electrolytic cell conductor is being used. Correct. So you will have a particular cell conductor here. You can see that here this way, wherein the entire outer layer here, correct, in this case the
Hmm.
outer layer what you have, this outer layer has a carbon lining here which will act like a cathode. Okay, outside there is steel, inside there is carbon lining. Okay,
Hmm.
and then we have a molten Al2O3 and Na3AlS4 mixed here, and we have this graphite rods, if you have noticed, is right. So there are multiple graphite rods which are kept in this solution, and they all are connected to a clamp, correct, which will serve as a
Yes, sir.
positive charged electrode, and the
Yes,
lining
sir.
here will act like a negative electrode. Okay.
Yes, sir.
What is the reaction that you expect? At cathode, we expect that the aluminum will take electrons and reduce into aluminum. At oxide, for oxide, we take O2 minus will oxidize into O2. Got it?
Yes, sir.
This is the cathode and anode reaction that you would notice. Okay.
Yes, sir.
And O2 reacts with anode from, CO or CO2. Clear?
Yes, sir.
So as to protect anode from oxygen, we use some powdered amount of carbon on the top. This process,
Okay.
as deterioration of anode, which means, see, On the molten form here, as soon as
Hmm.
the O2 which is released here, right, this O2 can
Yes, sir.
immediately react with the graphite rod and try to deteriorate it by converting into carbon monoxide or carbon dioxide.
Okay.
So just to avoid the deterioration, we can add some amount of powdered carbon coke on the surface of the liquid, molten liquid. Okay.
Oh,
So
okay.
that the released oxygen can immediately react with that carbon rather than directly reacting with anode. Okay,
Okay.
clear. And carbon addition is also going to decrease the amount of heat that is released. Okay,
Right.
Al2O3 is soluble by 15%, correct? And therefore, the ratio is such that you take 85% and around 10% of Al2O3 and 85% of cryolite. Okay,
Okay.
so you can see why add fluorspar is because its melting point is less than Al2O3.
Okay.
Ionization wise, CaF2 will have more ionization compared to Al2O3.
Okay.
Now, there is a chance that because F minus is present in the solution, F minus can also undergo oxidation to give two electrons. Okay.
Okay.
But as soon as the F2 minus is formed, it will immediately react with O2 minus present in the solution and it will again convert into O2 plus F minus.
Okay.
And
Yeah.
with graphite rod, O2 will react to give carbon monoxide or carbon dioxide.
Yeah. So.
So anode's main reaction is this only. Anode main reaction is O2 minus converting into O2. But because
Okay,
of
sir.
the presence of F minus, this is a reaction also being noticed. Clear?
Yes, sir.
The aluminium which is getting settled down will have a higher density compared to that of solvent. That's why it can be extracted at the bottom as a molten form.
Ah, okay.
Right. Now, let's see all the refining processes one by one. Okay.
Yes, sir.
Refining or purification is trying to make the metal extracted to close to 100% purity. Okay.
Okay.
So, reduction of an ore gives metal by removing some non volatile impurities, but some of the impurities might still remain. So, the final step is refining. There are various methods, starting first with distillation.
Okay.
Distillation is a process used when the heating of metal just above its boiling point keeps the impurities in the solid state and leave the metal in the in the vapor state. So those vapors are collected and condensed.
Right.
So that specifically this is done for zinc, cadmium, and mercury.
Okay.
Right. So when the boiling point of the pure metal is less than boiling point of impurities, such type of distillation process can be used. Okay.
Yes, sir.
Now, zinc, cadmium, mercury use DS2 and D10 configuration, and DD metal bonding is weak here because of the completely filled electrons. So there is a weak attractive forces between two zinc atoms or between two cadmium atoms. That's why regularly their boiling point is lesser than compared to the other impurities. Got it?
Yes, sir.
That's why this is more easier for zinc, cadmium, mercury to extract.
Yes, sir.
The next process is liquefaction. Liquefaction is a process when the impure metal is sloped on a surface, okay, an inert surface, correct.
Hmm.
In that case, a pure metal is obtained in liquid state and impurities remain in the solid state. Okay,
Okay.
so there
Yes,
is
sir.
a heated metal which, as you put it on the slope, if it slides down as a
Hmm.
liquid, clear, and just like
Yes, sir.
a Wolfray table, how we have it. Likewise, if the liquid is flowing down here, so that would have more metallic, uh, composition as compared to that of impurities.
Hmm.
This is typically used for tin, lead, and bismuth. Okay. Here, the criteria what you will look out for: melting point. So melting point of the metal should be less than impurities. Okay, beta.
Yes,
See,
sir.
tin, lead, and bismuth. These are heavy p block metals, and metal metal bonding decreases as you go down the group. Correct. Size is increasing.
Hmm.
Metallic character is decreasing further. Hmm.
Yes, sir.
The third type of refining is done by cupellation. Cupellation is a process when silver contains impurities of lead. So you are supposed to remove out lead as the impurity. Okay.
Okay.
This is called oxidative refining. Okay. What is
Hmm.
used? Silver is used. And see, this kind of a cup, a bowl, a bowl kind of a cup is called as cupel. In this cupel,
Cupid.
hot air passed and silver do not react with oxygen. Okay.
Okay.
Correct. If you remember the Ellingham diagram, we learned it that silver is unstable with oxygen at high temperature. In fact, the backward reaction is more favorable. Ag2O will
Okay.
decompose into silver. So silver does not have a lot of affinity with oxygen at high temperature.
ठीक
But
है.
lead has high affinity with oxygen at high temperature. Therefore, lead will form PbO, and PbO is volatile. Okay.
Yes, sir.
So in this cupel, what you do as soon as you blow the hot air into it, and you see cupel just like how we mix maybe a milk or some juice or something in the cup, right? So you keep on stirring it around. So as you keep doing it, lead will start converting into PbO, which will come out as vapors, and we keep on doing it till the entire shiny white color is observed on the surface of the cupel.
ठीक है.
So at that point, that means most of the lead has been removed out. Clear, beta?
Yes, sir.
The next type of refining is zone refining. Okay. In zone refining, this is a process where metal or semi metals in ultra pure form has to be extracted. Typically, this is done
Ultra
for
pure form.
silicon. Ultra pure is 99% pure. Okay. Hmm.
Okay.
99.99, sorry. Okay.
Okay.
So silicon, boron, gallium, germanium, arsenic, and so on. Indium. Okay, arsenic and indium and so on.
Okay.
These are metals typically used in semiconductors. This process is based on a phase rule. Okay. What is a
Okay.
phase rule here? Phase rule is this: impurities are more soluble in molten state in comparison to the solid state crystallization. See, think this way here.
Okay.
Suppose I have a complete rod here, correct?
Hmm.
And the entire rod has a mixture of metal and impurity. Okay.
Right.
Somewhere between the rod, I started heating it exclusively on that specific area. करेक्ट. जैसे आपने रॉड लिया बेटा, इमेजिन करो ऐसे
Hmm.
यहाँ पे फायर ऊपर की तरफ जा रहा है, एंड यू जस्ट कीप इट ओवर दैट फायर only at that
Okay.
point. So
Yes, sir.
when you are trying to heat only this particular zone, right, then here the metal will start becoming in molten form, correct?
Correct. Yeah.
So the phenomena with which the zone refining works is that in the molten form, the solubility of impurity is more. So that means the
Okay.
impurity from the side of from the solid side will start pushing itself into this molten state.
Okay.
And because of that, here you will start noticing more impurities. Okay. And left side and right side, you will have less impurities. Got it?
That is extremely random. Okay.
Got it? So that way, this is how you do it. See, if there is a metal like this, okay, in the air it is hanging. Imagine karo, both ends you have tied it with a rope or something. And you took
ठीक
a
है.
heater and you started this ring heater started moving slowly from left to right like this. Okay. So wherever the heater is moving, slowly that liquid zone is starting to move here. Got it?
Hmm.
So what happens wherever the liquid zone is moving, on that direction the mixing of impurities will be more.
Yes, sir.
So basically, you are trying to, pull all the impurities on one direction. So as it
Yes,
comes to
sir.
the end, you cut the end here. That's it. So what is remained? You will remain ultra pure metal. Okay.
Yes, sir.
This is the way you can j- get ultra pure metal using zone refining. Understood now?
Okay,
Right.
sir.
Next one is vapor phase refining. Okay.
Hmm.
What is vapor phase refining? See, metals form volatile compounds in the presence of volatile reagent. Okay. And this process
Okay.
is based on temperature difference. This process is based
ठीक है.
on temperature difference. Got it? And this is used for metals like nickel, zirconium, and titanium.
ठीक है.
Okay. Now, what is the function here? See, impure metal plus the reagent or the volatile form, the reagent which you add, which will become volatile, will react with each other, and the metal reagent vaporizes at temperature T1, and
Hmm.
impurities will remain. Okay.
Right.
And then metal and reagent are further heated at temperature T2. Okay.
Hmm.
So that the reagent which got vaporized will start converting into pure metal vapor separately and the reagent separately. Let me
Right.
show you how. See, think about it. Nickel is impure beta. Hmm?
Right.
It has some impurities of phosphorus, arsenic, something like that. The
ठीक
minute
है.
you react with carbon monoxide at around 40 and 50 degrees, you will start seeing the vapors of nickel carbonyl complex,
Oh, nice.
and the impurities will remain down. Hmm?
Right.
Now you take these vapors and you start heating them further, correct?
Hmm.
You can do it either way. See, you can first crystallize them. First, you crystallize these vapors, okay, and
Right.
convert that into a solid form. Hmm? And again,
Hmm.
you heat this time at a much higher temperature.
Right.
So when you do that, carbon monoxide will completely evaporate, and nickel will be the one which will remain in the solid state.
Hmm.
And here it is 99% pure. Got it?
Okay.
If you are specifically doing this for nickel, it is called as Mond's process. This is called Mond's process. Clear?
Hmm.
Next, if at all you're doing it for, you know, titanium, zirconium, hafnium, and boron, this is called Van Arkel process. Hmm?
Right.
Okay. In Van Arkel, we use iodine instead of carbonyl group. We use iodine here. So impure metal is heated with iodine at 400 kelvins, and then it is mixed to form, which is heated with tungsten filament at even higher temperature, which goes up to 1400, and then the metal is extracted. So same logic here also, metal plus I2 at around 400 kelvins will give you metal iodide, okay, plus impurities. And this metal iodide on strongly heating around 1400 kelvins will give you metal plus iodide.
This is the Van dudes.
Yes, Van Arkel
Right.
process. Okay, is this procedure clear?
Yes, sir.
Right. Okay. Next, notice what is Park's process. Park's process is about desilverification. That means this is ulta of that
That one.
cupellation.
Hmm.
Correct. Here, lead has to be separated, and silver is in a much smaller quantity. Hmm,
ठीक है.
Clear. Now, silver
Yes,
is
sir.
3000 times more soluble in zinc compared to that of lead. This comes with the part of an alloy nature. Alloy nature happens more easily when the sizes are more comparable. Silver and zinc size is more comparable. They have similar properties as compared to that of lead. That's why
Hmm.
silver will have more solubility with zinc as compared to that of lead. Okay.
Okay.
So in that case, what would happen? Zinc and lead does not form an alloy that easily. That's why in this composition, you add liquid zinc into it and heat it a bit. After heating, slowly you will start noticing most of the silver will start rising up and start mixing with the zinc. This is a molten form of zinc which you will have, wherein the silver will have more affinity, so it will get dissolved more with zinc. And the
ठीक है.
molten form below that will be mostly of lead. Okay, beta.
Okay.
And as you start using distillation, this mixture of zinc silver will come out as vapors, and that can be further condensed, wherein the silver will get separated, zinc vapors will get separated.
Okay.
And this, if you process through cupellation, right? Again, if you do the uh, through this cupellation, because now most of the lead is gone, right? But हो सकता है
Yeah,
now the
but
lead is present, but this time silver might be slightly more than lead. Okay, so again you
don't we want to
process
remove
cupellation,
silver?
again you get out silver, huh?
I thought we wanted to remove silver and get
We
lead.
did, right? The lead got purified here.
And then
This is the
उसके बाद
purified
again
lead.
for the silver zinc we
सिल्वर
are
कॉस्टली
removing
है ना,
silver.
छोड़ नहीं सकते.
Oh yeah, अच्छा हाँ. पैसा पैसा ठीक है.
कितना भी कम हो, सिल्वर को पकड़ना ही पड़ेगा.
हाँ,
सिल्वर, गोल्ड, प्लेटिनम, हर जगह पे हमको छोड़ना नहीं पड़ेगा उसको. ओके,
ठीक है.
कोई भी सिल्वर, गोल्ड, प्लेटिनम, ये मेटल्स के जो कॉस्टली मेटल्स के प्लांट्स होते हैं, उसमें दो ट्रीटमेंट कंपलसरी होता है. एक जो रेगुलर मेटल निकालना, दूसरा जो है these metals, precious metals को निकालना. ओके. So see, when silver and lead liquid is added, zinc with zinc, due to its density, lead gets separated, and thereafter distillation, silver will get separated with some lead impurity. Thereafter, cupellation is been done. Hmm? Done.
हम्म.
Another similar process, right? Instead of using zinc, right? अच्छा, मुझे जिंक यूज करना ही नहीं है, उस मेथड में जाना ही नहीं है. देन व्हाट यू डू अनदर प्रोसेस कॉल्ड पैटिंसंस प्रोसेस. ओके, here it
Okay.
is about desilverizing again. Okay, clear. Here also we are trying to desilverize,
Oh,
and this
okay.
is based on fractional crystallization. This is based on fractional crystallization. See,
ठीक है.
the melting point of lead and silver alloy is around 327, but the melting point of
हम्म.
pure silver, pure lead is 302 degrees. Okay,
Right.
so suppose if at all I first take this solid and bring it to the high temperature greater than 327, this mixture will start melting. Lead and silver will start becoming liquid state. Okay,
हम्म.
and as you bring it close to I mean, once you get this liquid form, now you try to put them in between the temperature 327 to 302. Then what happens?
Yes, sir.
Then lead will start converting into, you know solid form, and silver and lead will remain in the liquid form. So slowly from the bottom, with a very slow fractional crystallization, lead can be separated out. And the
हम्म.
surface liquid which is present, molten liquid which is present, that will again will have more composition of silver than lead. So you perform cupellation again, so silver can be removed out.
Okay.
Clear, beta? Right.
Yes, sir.
Next one is amalgamation. Okay, clear. This is a process to remove mercury. So mercury alloy is called amalgam.
हम्म.
This process can be based on difference in densities used for silver and gold metals. Okay,
Right.
right. Next, you can see iridium, platinum, and lead. They do not form amalgams easily. Just keep that in mind.
Okay.
They will not have similar affinity with mercury, but all other metals can easily have it. Okay,
Yes, sir.
clear. So in
Yes, sir.
amalgamation, basically steam is used. Steam of this mercury is used so that silver and gold will get settled down, and impurities, come upwards, and by distillation, silver and gold is separated out and Hg is vaporized. Okay.
Yes, sir.
Next one is electro refining. Now, like I said, This procedure is specifically done for molten state as well as aqueous conditions. Okay.
Okay.
Molten state, all the S block and aluminum. I told you
Yes,
sodium,
sir.
potassium, rubidium, cesium, magnesium, calcium, barium, strontium, they all are extracted in molten state only, along with aluminum.
Hmm.
In
Yes,
aqueous
sir.
state, iron, mercury, correct? Clear.
Yes, sir.
Uh, these they cannot be used in molten state, so they have to be not just iron, mercury. I mean all of them, correct?
Hmm.
Usually you extract all of these in different forms here. Check it out.
Yes,
Concept
sir.
is that the discharge potential, right? That is competition between the ions to discharge, right? That
Hmm.
discharge potential should be higher. Okay,
Right.
clear. Now the discharge potential in terms of reduction should be higher. Oxidation it should be lower. So check out. When it comes to gold plus 3, it have very high reduction potential. Then iron plus 3, then copper 2 plus, and as so on if you go, then you will get aluminum plus 3 and then S block.
ठीक है.
Okay. Typically check out for copper. Suppose if I take copper sulfate aqueous solution here, hmm, and I
Hmm.
want to extract the copper here, ठीक है? Pure copper.
Right.
Pure copper के लिए क्या करेंगे? First we will put cathode as a pure copper metal. The cathode
Hmm.
itself is a pure copper metal. Then we take an impure copper metal rod as the anode.
Okay.
Got it? So this is an
Yes,
impure
sir.
copper metal rod which is acting like anode. So what are we expecting? Anode, now at the anode part, you have to get an oxidation done. For oxidation, what are the reactions that are possible here? One is SO4 2 minus. SO4 2 minus can get oxidized 2 moles to convert into S2O8 2 minus plus 2 electrons. But for that, the E naught value is minus 2.5 electron volts. Sorry, 2.5 volts. Okay. Next, water getting oxidized to O2. For that, the E naught value is minus 1.34.
Yes, sir.
Then copper getting oxidized is minus 0.34. अब बताओ, out of these three equations, which one is most feasible?
Last one. Copper.
Last one. So which means, given the chance, there were three groups or three species which were competing with each other. Out of that, copper is
Copper.
the one which got, more ability to get oxidized. ठीक है बेटा?
Hmm.
And that would be copper is getting oxidized here like this. Okay.
Right.
And on the other hand, copper 2 plus which is getting dissolved here or already present in the ions here in copper sulfate, that will start getting reduced because reduction के लिए मेरे पास दो चीजें. Again, I have water
Hmm.
and copper. Reduction potential of water is quite negative, but copper 2 plus is positive. So which is more feasible? Again, copper 2 plus.
Hmm.
So that means copper is getting oxidized, copper 2 plus is getting reduced.
Right.
ठीक है बेटा? So in a way, here only the copper is getting deposited on the copper. So what happens? 100% pure copper is been
Pure
getting,
copper.
right, deposited on the surface.
Hmm. Yes, sir.
And impure copper भी यहाँ पे dissolve होते जा रहा है, right?
Hmm.
So this is the way you can make the impure copper start pushing towards cathode and become a pure copper. While
Right.
doing this, you will see there are certain metals which will get deposited here, which will get deposited here. Okay.
Right.
Which could be those metals? Can I say these are those metals whose reduction potential is greater than copper?
Yeah.
Isn't it? Reduction potential has to be greater than copper because they should have much more negative value of oxidation. Like for example, if it comes to silver, silver if it get oxidized as Ag plus plus 1 electron, E naught value is minus 0.8 volts. Hmm?
Hmm.
Like that. Gold is even more negative than this. Platinum is even
ठीक है.
more negative than this. Okay. So
Hmm.
what are the possible metals that could be present here? That could be present here. The metals that are present here would be silver, got it,
Hmm.
gold, and platinum. Okay, so platinum, silver, and gold, which can be found at this position, this is called anode mud. This is called anode mud. Okay.
Anode mud.
Hmm. Understood?
Okay. Yes,
Hmm.
sir.
So you can see that here. That's what we have written here. What is the reaction at cathode? What is the reaction at anode? What is happening at anode mud? Clear with copper, beta? Any doubt with electrolytic refining?
Nada.
The next process of refining is poling. Okay. So
Okay.
if the refining by reduction is presence in presence of a volatile agent, okay, this is a source of fresh green pole used, basically bamboo. Okay, bamboo poles are
Okay.
being used. Okay, which will give
Yes,
an
sir.
unburned methane on molten form. Okay, this is
Unburnt
used for
methane.
copper, tin, and lead. Okay,
Okay.
correct.
Yes, sir.
They all contain impurities of their oxides themselves. Copper might
ठीक
have
है.
some impurity because while extracting the copper, you might still have copper matte. In copper matte, again, you'll have some amount of Cu2s, which will still convert into Cu2O. So this kind of impurities will be there. Same is the
But
case with
what's
tin
the
and lead.
fresh green pole?
The fresh green pole is the bamboo. Okay.
And
Now see,
that's okay.
what we are doing is like this. You have a cupel here in which you have a mixture of metal and its respective oxide. Okay.
Hmm.
Now what happens? From here, you are sending a hot air into it. Okay.
Right.
And you took the bamboo, freshly, cut bamboo, cut into pieces,
Hmm.
add it to it. Okay. And why, once you add this, as you start heating it, you will get everything into molten form now. Correct.
Right.
And you are sending air, that means it will have oxygen. So you keep sending hot air into it. Okay.
ठीक है.
तो क्या होगा? Whatever the amount of hydrocarbon that is present here, correct, clear.
Hmm.
So sorry, whatever the amount of hydrocarbon that is present in the bamboo here, some part of that will get oxidized and
ठीक
some
है.
part of that will come out as CH4,
Right.
because this oxidation is not something via burning of material here, isn't it? It is happening within that molten form. Okay,
Hmm.
because of which you will sufficiently have unburned methane also present in it. Okay, beta.
Right.
So this unburnt methane in this hot condition will be able to help the impurities of oxides, impurities present in
Hmm.
the form of oxides, to get reduced in their into their metal form.
Right.
So Cu2O will get reduced to Cu, and CH4 will get oxidized to CO2.
Okay.
Are they clear, beta? This way the polling is being done. Okay.
This is why I skipped metallurgy in 10th. Polling.
Clear,
Okay.
beta? Hmm.
ठीक है.
Right. Okay. Now this is a part wherein we can quickly revise all the metallurgical extractions. So check it out. Quick review of all the metals once. Gold.
Okay.
Gold usually comes as natural source, okay,
Okay.
as rocks. And
Okay.
first we do gravity separation, which we call it as
Okay.
panning for gold. Then we get gold concentrate. Then we use
ठीक है.
MacArthur Forest cyanamide process
ठीक है.
with NaCN, O2, and zinc. You'll get an impure form of gold. We can use amalgamation or we can use electro refining. Both will help it getting gold out. Okay.
Mm-hmm.
Silver. Silver either gets as native metal as silver or Ag2S. Use MacArthur for forest cyanamide process, that is leaching. By the way, the process name is leaching. NaCN plus O2 and zinc, you will get silver as the impure form. You can do refining using cupellation, amalgamation, or electro refining. Depending on the
Okay.
quantity, depending on the source available, you can use it accordingly and get silver. Mercury, HGS. First, cinnabar. HGS is called cinnabar. That
Hmm.
use froth flotation method, convert into a concentrate first. Then make a complete
Right.
roasting to get HGO, which can give thermal decomposition to mercury, impure mercury, and then through distillation you can get pure mercury. Or
Hmm.
we learned that we can do partial roasting also, which will give HGS and HGO, which on self reduction will give Hg impure. Okay. Again, you do
Okay.
distillation, you can get pure mercury.
ठीक है.
Copper comes from copper pyrites, Cu2s, FeS, and FeS2 mixture. Through flotation, we can get the concentrate. Then we do partial roasting. Through partial roasting, we can get FeS plus Cu2s plus FeO plus
Hmm.
SO2. And FeS plus Cu2s, that can be done by self reduction here, which is bessemerization. Through
Right.
bessemerization, we can get copper, which is blister copper, and iron will exist as FeSiO3, silica will convert into SiO2. And this
Right.
is around 95% pure, but that can be done via electro refining, and then via poling, we can get copper in the pure form.
I see.
Next, low grade copper can also be used via hydrometallurgy. Okay, hydrometallurgy is like leaching. Got it? Hmm.
Hmm.
Next, I mean, this is the way you can do. First, you can do calcination. You can get Cu2O. This is typically done for low grade. Okay. Then after you
Okay.
can use pyrometallurgy. That is via carbon reduction. You can get copper impure, and then by reduction refining, you can get copper pure. Lead, which is galena, usually has ZnS as impurity. You do froth flotation using NaCN. You can get PbS. NaCl is used as a depressant to dissolve zinc sulfide. Then PbS is
Yes,
done
sir.
partial roasting, and from there you can get, uh, you know, uh, self reduction is been done. So we'll get PbS, and some amount of PbS plus SO2 will be present. That impure form, after refining, it will become a pure form. Lot of methods here.
Yes,
We
sir.
can use Parkes method, Pattinson's method, Poling method, liquation, as well as electro refining. Okay.
Yes, sir.
Tin. Tin can be done using magnetic separation. Wolframite is magnetic and SnO2 is non-magnetic. So that's how we can separate it out. Then low temperature roasting is been done so that SnO2 is formed. This will become CuSO4, FeSO4. On adding water, this will remain precipitate, rest will get dissolved. And SnO2, which we call it as black tin, using anthracite coal, we can get impure tin. Then after refining, you can get tin. What are the methods used?
ठीक है.
Poling, liquation, and electro refining.
Yes, sir.
Zinc.
Hmm.
Zinc presents as zinc blende, ZnS. We use froth flotation using copper sulfate as activator. You can get
Okay.
this concentrate, do the roasting, ZnO, react with carbon, you can get Zn. Zn on rapid cooling, you will get, I mean, carbon reduction, first will give Zn vapors. Rapid cooling, you will get Zn. Okay. Zinc, not Zn. Yes. Okay, only zinc. And that zinc is an impure form using refining method, which is distillation or electro refining. We can get zinc in the pure form.
तो ZNS का फुल फॉर्म क्या है?
Zinc sulfide. Zinc blend is the name.
Oh,
Sphalerite
wait,
is
I thought. is capital Z, capital N, capital S is like some process का short
नहीं
form.
नहीं नहीं, small n here.
अच्छा
ZNS.
ठीक, तो पता नहीं चलता आजकल.
ठीक है, fine. देखो, aluminium. Aluminium, we started off with bauxite. Bauxite has three types of impurities. If it is red bauxite, the major impurity is Fe2O3. If it is white bauxite, the
Mm-hmm.
major impurity is silica.
Okay.
Concentrate concentration can be done by two processes here: Bayer's process or Hall's process. See,
Yes, sir.
Hall's process is uh, sorry, Bayer's process first. Okay, where is it? Bayer's process.
Beer's process is तो aluminum, no?
These are all for aluminium only, beta.
अच्छा, bauxite is aluminum. My.
Uh-huh. So actually, Bayer's process is used via NaOH. I have not written that, but that is done by NaOH instead of Na2CO3. Okay.
Yes, sir.
So with that, basically you are getting sodium aluminate as the liquid, leaching. Basic leaching
Yes,
is,
sir.
and we remove the impurity of Fe2O3, and thereafter
Hmm.
adding it to water. Now this molten form will be there. This will be precipitated, and this aqueous form, when you add it with sufficient or sufficient amount of carbon dioxide, it will help this kind of base to react, convert back into Na2CO3 and aluminum getting precipitated. And that on heating
Hmm.
will give you Al2O3 again, but this time it is in a pure form, which is concentrated form. Okay, this is called alumina. The only difference between Bayer's and Hall's is here you take NaOH, here you take Na2CO3. Hmm?
Yes, sir.
For Serpex process, which is uh, you know extracting aluminum from white bauxite, so we take Al2O3. Considering there is silica impurity, you add carbon with N2 gas. Okay,
Okay.
on adding that, we'll get aluminum nitride. Carbon will get oxidized to get CO, and silicon vapors will be observed. And
Right.
ALN on hydrolysis will give you aluminum hydroxide, and that on heating strongly around 1100 degrees centigrade, you'll get Al2O3. That's how
Hmm.
you'll get alumina. Okay, beta.
Yes, sir.
And
Yes,
once you get
sir.
alumina, you can use electrolysis process, which we call it as Hall Herold process. Okay.
Yes, sir.
And once you get aluminum in an impure form, okay, we use Hoops process for purification. Now that I didn't explain earlier, I'll explain it here only. Okay, check.
Yes.
We take impure aluminium. Okay, impure aluminium. We add that impure aluminium with Na3Al F6, which is cryolite beta. Hmm? When you add cryolite here,
Yes.
correct, this way, when you add cryolite here, now the density of aluminium will be greater than Na3Al F6. Clear? Understood? And thereafter, as you start adding BaF2, the density will start increasing. Hmm?
Yes,
So what
sir.
happens now? Aluminium will be upwards here. Got it?
Yes, sir.
So you see, the pure form of aluminium which is forming will be the top layer. Then we can have Na3AlF6 plus BaF2 plus impure aluminium, and bottom layer will be only impure aluminium. Got it? So first you started adding impure aluminium, and as soon as you added with Na3AlF6 and BaF2, it will become something like a second layer, and this second layer will start. I mean, from there it can become aluminium pure. Okay. Done. Now the bottom part, which is aluminium impure, will act like a cathode, and the top part where we have aluminium pure along with this entire cryolite, that will act like anode. Got it? Sorry, here it is, anode side. My mistake. This one is the anode side, and this side is the cathode side. Okay.
Right.
So BF2, copper, silicon, these are used to increase the density of respective layers. Okay. Next, iron. You see, hematite, which is Fe2O3, that can be separate. I mean, we can remove all the impurities from it using magnetic separator. Silicon will be removed out. We can get impure iron in the form of Fe2O3. Do roasting and calcination. By chance, if there is any FeO, that will also convert into Fe2O3. Then we use blast furnace with limestone and coke, makes a carbon reduction to give impure form of iron, which has 95% iron with 5% impurity. And if the impurities composition reduces to only 2 to 3%, we call it as cast iron. If it is the purest form of iron, it is called wrought iron. And if it is in the form of an alloy, it is called steel.
So, um, pig iron is alloyed to form steel, or you first purify it to wrought or cast and then alloy it to form steel?
No, no. First, you need to convert that into wrought iron and then you convert into steel.
हाँ, okay. ठीक
Okay.
है.
No. See, pig iron, if you add more scrap iron here, correct, and add it to what do you say, a furnace here, correct, and then you heat it strongly, that will convert into cast iron. Okay.
Hmm.
So cast iron is mixed with this one in the presence of carbon and air, clear, in an impurity
Right.
oxidized by air. Okay.
Hmm.
Now, pig iron, if you do piddling process, piddling is like mixing like this. Okay. Correct. So by
Right.
piddling process, we can get wrought iron. Okay. So wherein we can see Fe2O3, right? The major impurity which is present is carbon here. Minor impurities include silicon, phosphorus, sulfur, manganese, and so on. Okay.
Right.
See, Fe2O3 has to be taken as oxidizing agent and flux. Okay.
Hmm.
So that means rest of them will convert into their respective oxides here, and iron will start getting into the pure form. Okay.
Right.
And some part of Fe2O3 and P4O10 can be mixed to give phosphate. And remember, phosphate slags are used in fertilizer industry, whether it is calcium phosphate or iron phosphate. Okay.
Hmm.
And manganese and silicon can mix with each other to become manganic slag, which can be used in cement industries. Okay.
Manganese slag. Okay.
Hmm. And you see, if you do not want to convert them into wrought iron, directly pig iron, if you use with some flux, correct, and whatever the element you desire to add, that element you mix it, maybe chromium or nickel or cobalt, whatever you add it with a right percentage, then you can get steel.
Okay.
Okay, beta. Okay, these are the processes just in case you wanted to check once. Okay. Hmm. Now, usually, if you have carbon, and nitrogen present in along with iron, correct, you make it into
Yes,
a
sir.
steel that is called hard steel. If you have
Yes, sir.
phosphorus and sulfur majorly present, that is called brittle steel. If element is manganese in it, it will give you high tensile strength steel, which will be used in
Why
railways
would you wanna
products.
make steel if you're gonna make it brittle?
No, it is essential in some areas because its uh, tensile strength is more. Okay.
किसका? Brittle steel.
Brittle का. So if you press it
Oh,
here, it will be harder, correct?
अच्छा ठीक है.
But if you make it with an angular stress, then it will break. Okay. Hmm.
अच्छा.
Next, if you have chromium and nickel, that will give you stainless steel. Okay.
Hmm.
So that will have oxide of chromium and nickel forming a protective layer. Okay.
Hmm.
Right. See, 95% of the manganese of the world population is used in making steel. Okay. MnO2
Yes,
is
sir.
mixed with Fe2O3 in blast furnace. Product obtained is called, okay, Spiegelstein steel, okay, or Spigen steel alloy.
Okay.
See, iron has mainly three types of treatments here, beta. One is annealing. Annealing is
Yes,
you
sir.
take a steel, heat it strongly up to 960 degrees. It will become red hot steel, and do a sudden cooling. On doing sudden cooling,
Right.
it will become a soft steel. Clear? Next is quenching. You take steel, heat it strongly, and then do a gradual cooling here in the presence of oil or water. Okay? That will
Hmm.
become a hard and brittle steel. Are they clear, beta? This is called quenching. So remember annealing and quenching. This difference is only with respect to cooling. Hmm,
तो थोड़ा कंट्रोल सर, थोड़ा प्रोसेस करने दो.
ठीक
इतना भी फास्ट नहीं है प्रोसेसर सर.